Hi, today we're going over section 1.3, which is mixed and entire radicals. So for this, we need to know the multiplication property of radicals, which is the nth root of a times b is equal to the nth root of a times the nth root of b, where a and b are positive numbers if our n value is an even number, because we can't take a square root or fourth root or any even root of a negative. We have different types of radicals. We have entire radicals and mixed radicals. An entire radical is when everything is inside our root. A mixed radical is when we've been able to simplify and take stuff in front of root. So root 20 would be the same as 2 root 5. We also have 3 root 6, 4 root 2. These two don't match these ones, but this would be the same value as this. So mixed radical just means we have something in front and then something inside. So for example, write each radical as a mixed radical if possible. We have the root of -75. So what I want to do when I do this is try to break these into two separate roots, one of which is a perfect square. So I would probably say I know that 75 is the same as 25 times 3, and I know I can get the square root of 25. So 75, so it's equal to negative root 25 times root of 3. We can take the square root of 25. We have that negative in front, so it becomes 5 root of 3. Next, we have square root of 42. Now, right away, nothing pops up that I can think of that multiplies to it that is a perfect square. So what I'll do is factor tree this to see if I can find any identical factors. So 42 is the same as 2 times 21, which is the same as 3 times 7. We can see we don't have any identical factors, so we can't change this to a mixed radical. Now, with a cube root of 54, I know that I can change that into the cube root of 27 times the cube root of 2. Now, cube root of 27 is 3, so we've got 3 cube root of 2. Okay, so writing as an entire radical, to take something outside of our square root and bring it inside, we square the number and then multiply it by the other term inside our radical. To take something outside of a cube root and bring it inside, we cube the number that's outside and then multiply it by the term inside our radical. So we have a few examples. We've got -6 root 5, 5 cube root of 3, and 2 fourth root of 5. Now when we do this, if we have a negative in front, we leave the negative in front, or else it will disappear at times if we have an even value root. So what we want to do, because this is a square root, we want to square of 6. So I'd give us 6 squared times 5. So that would be square root of 6 squared is 36 times 5, which gives us the root of 180. Now we did have a negative in front, so it still needs a negative in front. This one will be very similar, except for it's a cube root, so when we bring it inside, we are going to be cubing it. So 5 cubed is 125 times 3. Then we have the cube root of 375. Now this one's a fourth root, so that means we're going to go 2 to the power of 4 when we bring inside. So we have 2 to the power of 4 times 5. 2 to the power of 4 is 16. Multiply those together, and we have 80. Okay, so work for this section can be found on page 26. We're working on number 3, 4, 7, 9, and 14.